For this problem, we have a really tricky problem that looks difficult to solve. Even if students attempt to solve this problem, they will likely somehow mess up in between the work. Since it may look hard at first, but it is actually easy the more you practice this problem. So here is a hard example with 3 variables. Since we have x, y, and z, those are 3 variables. I also have this chart on the top right, the exponent rule. So when I mention a rule, exponent rule, you can see what rule I am mentioning. The first thing I would do is distribute this 2 right here, okay? And we're squaring this, okay? We could distribute this 2 into each of these variables and or numbers, okay? But the only thing you cannot do is when we have x plus y squared, because this, the incorrect way students would approach this would be squaring the x and y with x squared plus y squared. This is wrong. Instead of squaring them, we will have to multiply them. X plus y times x plus y. Since we are not adding anything in this parentheses, we could distribute 2 into each of these. So for the top one, I'm just going to rewrite everything to keep me on track. Okay, we have -2 squared. Be careful, -2 squared is going to be a +4. If the negative is outside the parentheses, it will be a -4. So be careful of that. So it's going to be 4. Okay, the parentheses will likely go away because we're not squaring anything. Next, we have x cubed to the second, x cubed squared. Okay, when we have this, we're going to have to use the power rule. The power rule says that we have a to the x power to the y power. So we're going to multiply both of the exponent, x times y. This is what we're going to do for this. So 3 times 2 is going to be x to the 6th power. Same thing for y here. This is to a -1 power. So it's going to be -1 times 2. So y is to the -2. Okay. Now that we get rid of that parentheses, we could solve this problem. Okay. Well, next thing I would do is to combine these, okay, combine the numerator, because that looks complicated to deal with if we just have a bunch of number or variables on in the numerator. So I'm gonna first get rid of those. Well, the first thing I will see is we have this 2 right here, 2 and a 2. Those are the only numbers we have in the numerator. So since it's being multiplied, is going to be 2 times the -2, which is going to be -4. -4. Now we have x to the -4 times x to the -2. What we're going to do is going to use the product rule. Since they have the same base, we can add the exponent, okay? No matter if they have negative exponent, okay? Well, another way that student would do is to bring the exponent in the denominator. You could do that, but I like to combine them, simplify them first before I bring them in the denominator, okay? Because we need them to have positive exponent, because that's going to be the negative exponent rule later on. X to the -4 times x to the -2 is going to be x to the -6, because we're adding them. We're not multiplying, okay? You can only add them if they have the same base, which they do. So x to the -6. Now we have y squared times y to the -4 power. Add them again using the product rule. It's going to be -2. And the same for the variable z. -4 plus 4 is going to be z to 0. Now we can rewrite everything in the denominator. You see how we went from this to a more similar form to deal with. The next thing I see is the -4 divided by the 4. That's going to be a -1. So instead of writing a -1 in the numerator, I could just put the negative sign in the middle of the fraction. So, okay, now the 4's are gone. Okay, now we have x to the -6 over x to the 6. Okay. For this, we have to use the quotient rule, where if we're dividing the exponent, or you can say the variable, we have to subtract their exponent. So we have x to the -6 minus 6 going to be x to the -12. The same thing for y, that's going to be y to 4. But you see, anything to the 0 power is going to be 1. We're going to use the 0 exponent rule. So since it's z to the 0 power is going to be 1 right here. Okay, that's multiplying 1. Okay. Now everything in the denominator are gone. So this is just 1 in the denominator. Or you can just remove that fraction. Doesn't matter. But since I just put the 1 in the denominator because I'm going to be moving the x and y because they have negative exponent. We're going to be using the negative exponent rule where we have any variable to the negative exponent. We could bring them in the denominator. If they're in the denominator, we bring it in the numerator. Since x and y have negative exponent, we could bring them in the denominator since they're in the numerator. So we're left with 1 over x to the 12th times y to the 4th. Oh, there was one mistake that I made with this problem. As you can see, this y over 4 is going to be wrong because I did a common mistake here. I did -2 minus 2, which gave me -4. But since this is a -2, it's going to be -2 minus a -2, okay? So we just distribute this negative sign into this. This is going to be -2 plus 2, which equals 0. Be careful of mistakes. You can see that I made a mistake in this problem, which is fine because you can learn from your mistakes. So I'm just going to erase everything. This is going to be y to -2 minus a -2, which is going to be y to 0 power times 1 over 1. Y to 0 is just 1, so we're left with x to the -12 power over 1. Since this is a since x is a negative exponent, we could bring in the denominator. So we're left with 1 over x to the 12th. But don't forget your negative sign, okay? So it's gonna, all right, final answer is gonna be -1 over x to the 12th power. It's gonna be our final answer.